question 34 of civil engineering paper of GATE 2017 afternoon session. Two identical concrete piles having the plan dimensions 50 cm by 50 cm are driven into a homogeneous sandy layer as shown in the figures. Consider the bearing capacity factor NQ for phi is equal to 30 degree as 24. If Q P1 and Q P2 represent the ultimate point bearing resistance of the pile under dry and submerged conditions respectively, which one of the following statements is correct? So, in this question, two conditions are given. In the first condition, the soil is dry sand, and in the second condition, the soil is saturated sand, having the phi is same for both the sand. And the concrete pile in both the conditions are same. The cross section and dimension are same for both the concrete piles, and depth of foundation is also same. Now we need to compare the ultimate point bearing resistance for both the piles. So this question is from the topic of pile load capacity. You may study about this pile load capacity and how to calculate the ultimate bearing capacity of pile. There are various methods to compute them. So you may study in details in lecture 29, Pile Foundation, Foundation Engineering by Professor Kaushik Dev, IIT Kharagpur. So in general, the equation for point bearing resistance QPU for a C file may be written in the form QPU equal to CNC plus sigma dash NQ plus 0.5 gamma BN gamma, where B is the width or diameter of the pile, sigma dash is the effective overburden pressure, can be calculated by gamma into depth of this foundation or length of the pile. NC, NQ, N gamma are the bearing capacity factor, which is a function of phi, that is in angle of internal friction of the soil. C is the unit cohesion. L is the length of embedment of the pile. Gamma is the effective unit weight of the soil. In the deep foundation, it is observed that this term 0.5 gamma Bn gamma is quite small as compared to this sigma dash NQ. So this term, that is 0.5 gamma Bn gamma, is neglected for this deep foundation. So the equation for QPU, that is ultimate bearing capacity of pile for a C phi soil, or this is ultimate point resistance of a C phi soil, can be written as CNC plus sigma dash NQ, where C is this cohesion of the soil, NC and NQ is the bearing capacity factor, and sigma dash is the effective overburden pressure. Now, since in this question this soil layer is given as sand, so we know for sand the value of C is 0, so we may write for sandy soil, QPU, that is ultimate point resistance of the pile, can be written as sigma dash NQ, where sigma dash is the effective overburden pressure and NQ is the bearing capacity factor. So in this question, these two conditions are given. Okay, so for the first condition, for this QPU P1, so QP1 is equal to sigma dash NQ. So sigma dash will be gamma into df, where df is the depth of foundation or length of this pile, into NQ. So the value of gamma is given as here 18. So this is 18. Into this depth of foundation is given as 20, and this is NQ. Okay, so this will be 360 NQ kilonewton per meter square. Now for second condition QP2, again the formula will be sigma dash NQ, but here the soil is saturated sand. So the gammas, this sigma dash, that is effective stress, can be written as this gamma submerged into df, into NQ. Since NQ is same for both the conditions, so I am writing here NQ only. Okay, so gamma submerged is 19 minus 9.81, we can write, that is saturated unit weight minus unit weight of water into depth of foundation is 20 and NQ. So this will be 183.8 NQ kilonewton per meter square. Now when we compare this QP1 and QP2, so it can be observed that this QP2 is almost half of QP1, or we can say this QP1 is almost twice of QP2. Okay, so we can say that QP1 is almost twice of QP2. So now in this question, the option is we need to compare this QP1 and QP2. So we have just observed that QP1 is almost equal to twice of QP2. So we can say that QP1 is greater than QP2 by 100%. Okay, since it is double, almost double, so we can write that this is 100% more than this value. So in this option we can say this QP1 is greater than QP2 by about 100%. So option A is the correct answer for this question. Thank you.